Hello there! Today is day 35 of working on a currently untitled project, so let's hop right in. So today I wrote the code for merging the one big mesh, and actually merging the vertices together so that they collapse properly. Easiest way to show this is to zoom in really far here and see that when I stop the game, you can see actually there's these tiny little gaps that form. Well, not tiny little gaps. It's just you can just barely see that this vertex, lines, it goes outside like that, is by the tiniest fraction of a centimeter. And when I play, that goes away. And then I had to change it up because I actually need to break it into multiple smaller meshes because of a visual glitch. When it was one big mesh, it started doing this, where you have, it looks normal when it's like that, and then when you go and merge it all, you have that problem because this here draws after these guys here draw. So yeah, whoops. Anyway, so I did go ahead and rewrite it so that it now does not have that visual glitch. So if I go ahead and take this material and set the opacity to 100%, it no longer has that bug. So that's pretty good. I also added in coloration of the vertices. The vertex colors are shared for any given spot that they merge to. The vertex colors are shared right now. So you see that even though they're distinct objects here, it looks continuous across it. It doesn't look like there are hard edges. So this is progress towards what I want to do for the what I want to try out for the visual style for the walls. Again, I don't know if it'll actually work out all that well when push comes to shove, but yeah, it's worth a shot. Anyways, that's all the core stuff. If you want to listen to me ramble, feel free to stick around. If you want to just click off the video, feel free to do that as well. Anyways, my rambles this time around are just discussing the challenges I faced with what happened. There were two really big bugs I had to deal with. One was when I was merging the really big mesh. I had this issue with the splits. So I'm doing spatial partitioning to speed up. That was one thing I meant to do. I meant to log out how long it takes to merge this one big mesh here, or merge all the smaller meshes together. I want to see how long that takes, and how long it takes to generate everything. It should not take long at all. Basically, there are a lot of vertices. To speed it up, I'm doing spatial partitioning to make it so I don't have to compare one vertex against a vertex over here. So I partition things on the x-axis, which is straightforward enough. That's the simple version. The thing is, you have cases like this where you're going to have a lot of vertices that are all lined up on the x-axis, right here, and then it just continues all the way up here as well. So I'm also partitioning on the y-axis. Partitioning on the x-axis alone is super simple. You just take all the vertices and you just sort on the x-axis, and you're done. Partitioning on the y-axis is a little bit more difficult because you need to be able to search that without. I don't know how technical people want me to get in these recordings, so short version, this is the code for partitioning on the x-axis, and this is the code for partitioning on the y-axis. So partitioning on the y-axis isn't difficult in and of itself, but you just have to be a bit clever with it. So I partition on the y-axis first. I say, hey, just split everything into these groupings, to, vertically, so you have these slices, and then take all these vertices and sort, low to high across the x-axis. Wherever the vertices are placed. Usually in little clusters like this. So round to the nearest int based on the split distance, and then sort, or then add that as a vertex. This here is just complicated. This is just really complicated lambda for saying, hey, if I can actually rewrite this to be more clear. Because I wrote a helper function to help make this not really cringeworthy. I just didn't apply it everywhere because I'm bad. So if A is less than B, then it's less than. If A is greater than B, that's greater than. Otherwise it's 0, meaning that's equal. And so just sort on the x-axis. So basically that's just saying sort on the x-axis low to high. The merge verts in layers thing, because each I'm saying that each of the y-axis splits is a layer. So to do that, I need the current layer and whatever layer is next in line. The reason for that is if there's a vertex here and a vertex here, let me just color these red so that they stand out. If there's a vertex here and a vertex here, and these two are close enough that they can be merged, the only way to tell that they can be merged together is to check both this layer and this layer. The problem that I had run into was I thought, oh, I can be really clever here. I can just say add yourself to your current layer and also add yourself to your nearest layer. And so you'll be in both layers, and that solves that problem. And it does for that particular case. Then you only need to check one layer because, hey, you check this layer and you find both vertices. And you find, hey, both of them are close enough, you can merge them. The problem is that what happens when you have a vertex here and a vertex here, and these are close enough that they can be merged, then this vertex, adds itself to this one here, and also, the bottom one, and this one adds itself to the top one, and then you run into the same problem where, hey, you check, and you find this vertex in this layer, and you say, oh, what can it be merged with? Oh, well, nothing, because there's clearly no other vertex in this layer that is close enough. So basically, long story short, you have to check 2 layers at once. Or when you are checking one layer, you have to know about the next layer, and you have to look at it and examine it as well to see if there's anything that can be merged. Anyways, so that was the problem that I faced there, was that I should probably break this up into multiple functions, but I'm lazy about that. Basically, for all the vertices in any particular layer, look to the right, see if there's any vertices that need to be added, or any vertices that are close enough that they can be merged together. Basically repeat this process for the second layer, although you can't just use where you're at initially. You have to find that with a binary search to get to get the first vertex that is applicable. And these are not great variable names, but anyways, repeat the process to see, hey, are there any vertices that can be merged? At the end, the vertex groups, this is a thing that I do, this line is no longer needed. This is just tracking the groups of vertices. This is for the coloration. Then average the final position, and then set all the vertices to have that final position. And this is for debugging. And mark all the vertices as checked. Yeah, anyways, yeah, so that's the algorithm. And for the colors, just for each of the vertex groups, generate a color and then assign the color to each vertex in the group. The colors corresponds to the vertices. And then generate the meshes. Yeah. So the second bug that I ran into. The second bug that I ran into was stuff wasn't merging properly after I swapped to the mesh vertex system for all the sub meshes rather than having one big mesh, having multiple meshes. And that was just, I forgot to write these 5 lines of code. And so it was because, if you're trying to see, hey, has this vertex been checked already? Because if a vertex has been checked already, it's been merged already, and so therefore you don't want to merge it a second time. Without this little bit right here, this wasn't sorting properly, so it wasn't finding things correctly, I think, and that just meant that it checked the same vertices multiple times sometimes, and that bugged out. And so the colors were wrong, and when you did the debug position thing here, sometimes this was applied multiple times, and now it's not. So yeah, those were the trials and tribulations I went through today. Hopefully that was interesting to somebody, at least. Hopefully that was also understandable enough without being overly technical or not technical enough. Let me know if you have any feedback on that, if you're watching this, and I can adjust in the future. Yes, sir, I shut off the vertex clause, yes. Yeah. If you have any comments, questions, ideas, or anything else on your mind, leave a comment below. Thank you for your time, and I hope to see you again soon. Take care.